Welcome to the Regents Introduction to Measurement video. In this video, we're going to do what should be a review on some basic measurement and calculation topics. Nonetheless, we're going to jump right in here. The first thing we're going to talk about is knowing your metric prefixes. There are some that we use more in physics than we do in other courses or math settings. And I will tell you up front that there is a chart on your reference table that has all the metric prefixes and their corresponding powers of 10. But we're going to highlight some here that would be nice to know so that we don't have to go run to the reference table and we just be on the top of our minds and not waste the time, especially in an exam setting where we'd have to go look those up. So we're going to start small and work our way large. We're going to start with 10 to the negative 9, which is nano. Probably the most common use of nano in our course is going to be nanometer, which is what the wavelength of light is often expressed in. Now, you may have also heard of nanotechnology if you're kind of a person that keeps up on science topics. So nano, 10 to the negative 9. 10 to the negative 6 is micro, and micrometer, microsecond. Microcoulomb is a unit of charge in electrostatics, and that means 10 to the negative 6. 10 to the negative 3 you should be familiar with, and that's milli. And millimeter, millisecond are some examples there. 10 to the negative 2 is centimeter. And then you notice we jump right up into positive exponents here in larger quantities. 10 to the third, 1,000, is kilo. Kilometer. Kilogram is the standard unit of mass in physics. And it's not the gram, but the kilogram. And then we have 10 to the 6, which is a million, and that's mega. One of the units here we'll learn this year when we do energy is mega electron volts, which would be 10 to the 6 electron volts. You'll also hear that nickname million electron volts because, of course, mega means 10 to the 6, which is million. And then 10 to the 9, which is giga, and probably your most common unit you've heard there is gigabytes, for example, and that's a billion. Gigahertz is another example, a unit of frequency. All right, let's move on. We're going to talk about conversions and using dimensional analysis. First of all, what is dimensional analysis? You may want to jot this down. Dimensional analysis is treating units like algebraic quantities in order to get to other units, in order to convert to other units. Treating units like algebraic quantities in order to convert to other units. This can be done, in this case, we have an example of converting time units. We could be doing within the English system, we could be converting units within the metric system. And we could also convert in between the English system and the metric system using dimensional analysis. So I'm going to model that for you by doing this sample problem here. How many seconds in 1 year? So we start with a year, and simply in dimensional analysis is all you do is you take and you multiply by fractions, canceling out one unit and getting another until you're at the unit in the end that you want. So probably what we would do here, if we wanted to get rid of years, years would have to go in the denominator of this fraction so that when you divide, years cancels out. And probably what most of us would do here is convert to years to days. So most of us know 365 days in 1 year. That's on average, of course. So that cancels years. Now we want to multiply by another fraction to eliminate days. So where would we have to put days? We would have to put days in the denominator to cancel out. Most would then convert to hours to do this, another time unit. And of course, 1 day is 24 hours. Days cancels. So now we're down to units of hours. We need units of seconds. Most of us would then go hours to minutes. And of course, 1 hour is 60 minutes. Hours cancels. And then lastly, converting from minutes to seconds. To get rid of minutes, minutes would have to go in the denominator. And seconds would go in the numerator. And we all know 1 minute is 60 seconds. Now we just have to do the math of all the fractions that we have here. This would, of course, be 365 times 24 times 60 times 60 divided by the product of all our denominators, which is all 1. Easy enough. Go ahead on your calculator and calculate that. And whenever we do these kind of videos, it is really important that you actually do the sample calculations and not just rely on the video for the answer for practice. Otherwise, you get nothing out of it. You get no practice manipulating the numbers on your calculator. So pause the video, go ahead, grab your calculator, and do that calculation, and then come back in a moment here and check your answer. You should have got 3153,6000. So 31,536,000 seconds in 1 year. You can just use S too for seconds. You don't need to write out SEC. Alrighty, so there's a sample for dimensional analysis. We'll have much more on that to come throughout the year. Our next topic is simply a review of scientific, also called exponential notation. We often write large numbers and numbers with a lot of decimals in scientific notation in physics. So let's do this practice. For example, express 9,192,631,770 in scientific notation. Of course, that would be 9.192631770 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, and 9. We'd have to move the decimal place 9 digits to the left, and so that's times 10 to the 9th. Okay? And that would be how you would express that number in scientific notation. When adding or subtracting, what's important to remember is that the numbers must have the same power of 10 in order to add or subtract numbers already written in scientific notation. When multiplying numbers, you have to add the exponents of the powers of 10. And when dividing, doing a calculation where you're dividing numbers in scientific notation, you subtract the exponents of the powers of 10. Okay? All right, our last topic is going to be order of magnitude. And I suspect this is a brand new topic for everybody taking the course. Let's start off with a definition. What is order of magnitude? Order of magnitude is simply the power of 10 that a number or a measurement is closest to. The power of 10 a number is closest to. We're going to use my baseball jersey number when I'm coaching as an example here, and that's 15. So one might ask, what is 15's order of magnitude? What you're really asking is, what is the power of 10 that is closest to the number 15? What you do here is you establish between which two powers of 10 does the number 15 lie. Well, 15 lies between 10 to the first, which is 10, and 10 to the second, which is 100. And as beginners, I do encourage you to write the actual number underneath the powers of 10 until you get good at this. Then the question becomes, okay, which power of 10 is closest to 15? And it's pretty easy to see that that would be 10 to the 1. So 15's order of magnitude is 10 to the 1, or we could just say the exponent and say 1. So the answer would be 10 to the 1 or 1. Both answers are acceptable. Let's change my Jersey number over to a decimal now. What would be 0.15's order of magnitude? These are a little bit trickier. Got to be a little careful when we're doing the decimals because we're dealing with negative exponents. But as the negative number gets larger, the actual number gets smaller. So we got to be careful about that. All right, so between what two powers of 10 is the number 0.15? Well, on the low side, that would be 10 to the negative 1 is the power of 10 just smaller than 0.15, which would be 0.10 or just 0.1. And the power of 10 that is larger than 0.15 would be 10 to the 0, which is 1. Just do a double check on these ones that are a little trickier. Is 0.15 between 0.10 and 1? And the answer is yes. Which power of 10 is 0.15 closer to? And clearly the answer is 10 to the negative 1. So 0.15's order of magnitude would be 10 to the negative 1 or just negative 1. Let me give you another example and see what you come up with here. What is 500's order of magnitude? Maybe this one will be a little tricky because it seems like 500 is that halfway point in which we would round to the next higher number there, like we're used to doing in traditional math. So let's check it out. Okay, 500, the power of 10 smaller than 500 is 10 to the 2, which is 100. And the power of 10 larger than 500 is 10 to the 3, which is 1,000. Okay, does 500 lie between 100 and 1,000? Yes. So we've correctly selected the high and low powers of 10 here. So which one is 500 closer to? What's the order of magnitude for 500? One might say, well, it's halfway, so we round up, so we would select 10 to the 3. Let's double check that. The difference between 500 and 100 is 400. The difference between 500 and 1,000 is 500. Aha. 500 is actually closer to 10 to the second than it is 10 to the third. So 500's order of magnitude would be 10 to the 2 or just 2. The important lesson here, and the reason this was assigned during the video here, is that 500 is not the halfway cutoff point for order of magnitude rounding. That would be 5.5. 5.5 times 10 to the anything would be the halfway cutoff point for order of magnitude in which you would round up to the next highest power of 10. Okay? All right, let's do a couple practice examples here. What is the order of magnitude of a building that is 78 meters tall? Well, we take 78. Between what powers of 10 does 78 lie? 10 to the first, which is 10, and 10 to the second, which is 100. So between what powers of 10, which one is closest to 78? Well, 78 is greater than 55, which would be the halfway cutoff point, and so the answer is 10 to the second. All right, let's do one that's a decimal to wrap it up. 0.0006. What is the order of magnitude of particle diameter? 0.006 meters. On the low side, that would be 0.0001, which is 10 to the negative 1, 2, 3, 4. So the one larger than that is 10 to the negative 3, which is 0.001. 6 exceeds the halfway cutoff point, so we round to the next highest power of 10, which would be 10 to the negative 3. We'll have much more practice with all these concepts here at the beginning of the course, and so more to come.